Hello and welcome to CMTEQ Engineering PodCAST. This is the space where we explore the pulse of electrical engineering and technology that is shaping our world today, right? So whether you are a student who's basically starting out with your studies in electrical engineering, or maybe a professional already working in a field on various fields of electrical engineering, or perhaps maybe you are just someone who's curious about how electricity powers everything around us, right? You are in the right place, my friend. I'm Chad, your host, and I've been working in electrical engineering for over 15 years, and I'm the person behind the CMTEQ YouTube channel. Basically, from designing embedded systems to analyzing power grids, I've had a front row seat to the evolution of this field over the past 20 years. This is why this podcast is going to be your weekly fix of engineering insight, industry trends, and deep dives into both foundational concepts and cutting-edge innovations, where I'll be sharing my experiences and my insight in various fields of electrical engineering. So this is just going to be pure engineering talk, where we will be discussing the design specifications of various engineering projects and also how different fields of engineering come together to create innovative ideas and functional product, right? It's all about the merging of certain the disciplines of electrical, mechanical, software, and more, working in harmony to turn complex ideas into real-world solutions. So, having said that, in today's episode, this is episode number 2 of the CMTEQ Engineering PodCAST, and in this episode, we will be answering a very common question that I get a lot, especially from young students, where they usually ask, is electrical engineering still relevant today, right? Well, let me tell you, it's not only relevant, it is basically at the center of every major technological shift that's happening right now. So that's what we're going to cover in this episode. We're basically going to answer the question, why is electrical engineering still relevant today in 2025 and beyond? So if you want to know the answer to that question and many more, make sure you stay put until the end of this podcast. Okay, so why electrical engineering still matters? That's a question. Now, to answer this, let's just take a moment and step back and just think about it. What exactly is electrical engineering? That is the question, right? Now, at its core, it's basically the study and applications of electricity, electronics, and electromagnetism, right? So you got electricity, electronics, and electromagnetism. But that's just the textbook definition, okay? That's just the textbook definition. Because in the electricity, electronics, and electromagnetism, you got other subfields, categories that can be studied, and many students go through those fields of studies. But in real life, or in reality, electrical engineers are the ones building the systems that power your home, right? The system that charge your devices and run your electric vehicles. For those of you who are already driving electric vehicles. Now, we electrical engineers, we are basically behind the infrastructure that keeps your lights on. Your hospital equipments, they basically all electrical engineering's product. And your favorite gadgets that operate smoothly, your smartphones and all of those, right? Just to name a few, you can just think of them. Anything that works with electricity that require a battery, that is an electrical engineering product. Okay? Now, and here is the truth. There are no other tech fields that exist without electrical engineering. Now, that is something very strong to say, but I'm saying it. There are no other fields of technologies that exist without the intervention of electrical engineering. Okay? So, let's take, for example, AI models. Okay, we got all of these large model languages. Now, they all run on GPUs, right? That are powered by what? Electrical systems. Okay? Now, space mission, you want to talk about space mission? The satellites, they all rely on complex power electronics and embedded control systems, right? So, that space aircraft that is being fired up as you see it being launched, there is a lot of power electronics and control system going on there to make the mission successful. And let alone the embedded software that's thousands and hundreds of thousands of codes that's been hard coded to ensure that that entire spaceship is a product and it needs a firmware. Okay, now this is really crazy stuff. It needs a firmware that must ensure that everything is synchronized and work together. Now, that's electrical engineering. And smartphones and the equipment I'm using right now to do this podcast, they are all electrical engineering product. And obviously, you do have a merger of mechanical systems, especially for control system and things like that. But at the core, it's electrical engineering. So, in your smartphone, you've got that PCB that is in there. Some of them flexi PCB. Now, without the PCB design, signal integrity and efficient power management, nothing will work in your smartphone. Even software developers, they depend on the hardware we help basically create. So if I create, okay, let's just talk about a smartphone. Now, there are people who are busy developing software applications, apps that you can find on Play Store on iPhones. Those are software developers who are writing those software. But they need that platform, that smartphone, right? Before they can do that. So that's still electrical engineering. So now we are in 2025. And the importance of electrical engineering is only growing, okay? It's not shrinking. The electrification of everything is real. Homes, cars, factories, even entire cities are shifting towards electric power in terms of renewable energy sources like wind and solars. Now, they need inverters, okay? And inverters, they are made of converters and storage systems, right? Battery banks, which all need electrical system like battery management system, BMS, and others. Now, these are all designed and managed by electrical engineers. Now you get the picture. Now, and yet, a lot of people overlook this. Some even think it's a dying field. I mean, that's crazy to think that, right? Now, the truth is, electrical engineering is evolving. It's not disappearing. So, yes, it still matters. And more than ever, I will add. Now, the world needs engineers who understand how to design safe, efficient, and reliable systems or reliable electrical systems. So that's about that. Okay, now while I take a quick sip of my coffee here, and the water to make this coffee was made out of a kettle, right? That's got an element that heat up to produce hot water. Now the control system there to stop the kettle when the water reach that boiling point, it's also an electrical system. Okay, Now, let's just dig into the trends pushing electrical engineering into a whole new era. If you want to stay competitive, these are the areas you need to pay attention to. Now, pay really attention into the top 5 trends in electrical engineering right now. So we've got number 1, artificial intelligence, AI in power systems. Now, as you know, my channel CMTEQ mostly focus on power system analysis, and very soon I will be shifting into the integrations of artificial intelligence into power system, because we are heading into that direction. So AI isn't just a software buzzword. Now it's transforming the way power grids are managed. Predictive maintenance, right? That's the main thing, especially in power systems. You want to ensure reliability of supply. You don't want interruption. But we can only be ready and ensure that we've got a circuit breaker who are ready to act and break the circuit in case of short circuit. Now, we cannot prevent extreme weathers from interrupting the power system. But with the merge of AI in power system, we can do predictive maintenance. Basically, algorithm that will monitor transformer health, breakaway, and cable degradation, so that we can really say, okay, within the next 5 years, we need to do maintenance. Obviously, right now, we rely sometimes on routine maintenance to ensure things are kept in the best shape. But with AI integration, it's even gonna get better. Now you got load forecasting. Now, grid operators, they use machine learning to better predict demand fluctuations. Now, that will be more efficient instead of just looking at the data. So let's say we are now in July 2025, and if we had to forecast how the power consumption will be in this July, we would have take care of looking at the data last July and then adding other parameters, and that will now inform our decision in forecasting the power demand within July. But if you implement machine learning, you even going to do that bit better, because then you don't need a lot of human intervention. Now you have also grid automation, which will actually come in for intelligent switching that reduces outages and balances loads instantly. Okay, so that is another major area where AI can come in power system. And then we also have number 2, that is EVs and power electronics. So you got your electric vehicles and power electronics. Now, electric vehicles aren't just trendy, right? They are actually a massive engineering challenge. So power electronic must handle high voltage with minimal losses. So that is your boost conversions, back and fly back, all sort of converter circuit that must operate within that specific system. So new materials like SiC, the silicon carbide, and GaN, gallium nitride, they are pushing limits in charger efficiency, inverter performance, and also thermal management, which is one of the main one of the main requirements in these power electronics modules. Okay, now engineers, they now need to understand battery management systems, DC fast charging system, and motor control system. All comes in together in these EVs design. So that is number 2, right? Now remember, number 1, AI in power system. Number 2, electric vehicles and power electronics. Number 3, smart grids and IoT integration. Now we're coming back into power systems again, because remember, we start powering our world, we're gonna move back right into Stone Age. So we still need to power our world. Therefore, we need smart grids and IoT integration. So we are moving from dumb power lines to intelligent infrastructure. Okay, so what do I mean by that? It's basically the integration of smart meters, real-time monitoring systems, and automated control. Okay, now we've mentioned a bit of these with the AI and power system, and those automated control, they will basically allow for decentralized energy system. Instead of having the central grid that control the hubs and all of that, you're going to have the system a bit more decentralized, controlling from diverse areas. Then you have the integrations of distributed energy source, or also known as DERs, right? And the likes of rooftops, solar farms, and battery storage. These come together, they makes grid balancing more complex when they are added into the grid, because especially if these systems are not properly regulated, they can bring in different type of issues into the grid. Therefore, we need smart grid to actually control all these integrations. Right now, this is very interesting stuff. Okay, so that's number 3. And number 4, embedded system everywhere. Remember, on the first episode of the CMTEQ podcast, we talk about breaking down embedded system for beginners. Okay, and at number 4 here, we've got embedded system, which is now everywhere. Now, whether it's a microcontroller in a drone or a sensor in your washing machine, embedded systems, they are behind the scenes. They are right there. You don't see them, but they are there. They are behind the scene. It's like your back-end code on your smartphone. You are there busy pressing buttons on your smartphone applications. At every button you press, there is something that's taking care of that is handling it. It's an event handler. Now the event handler is a back-end code that is working right there. So that's like your embedded system. They are everywhere. Now the demand for low power real-time control has exploded. Okay, so you need a powerful device, but that must not consume enough power. So your cell phone battery must last longer. And we've seen improvement. Really, smartphone batteries, they used to not last long. These days, even low-end smartphone, the batteries are lasting longer, because the technologies that are being implemented now, it's low power consumption. You've got a lot of controllers that actually goes into sleep mode when your device is not being used. Okay, that's why you see your phone, it's come automatically. You can set the control, but as soon as you leave your phone, the screen goes off 5 seconds, right? And as soon as the screen goes off, a lot of other controllers, they just power down to reduce the power consumption from your battery. That way you extend the period, the frequency of charging your battery. We've got MCUs like the STM32s, your ESP32s, and your TI C2000 series. They are everywhere in lots of devices that you see around you. And engineers who can write efficient firmware are in high demand. Even though there is a threat that artificial intelligence can write better code than humans, but we still human for certain decision making and implementation. So engineers who can write efficient firmware, they are in high demand right now and in the near future. So you combine that with wireless protocols like BLE, the ZigBee, the LoRa, and you've got the heart of the modern smart devices. That's it. That's basically it. Now, number 5, that is simulation and digital prototyping. Now, this is a very interesting one. Now, gone are the days of trial and error on breadboards alone. I mean, as students, we had those episodes where you need to wire an entire digital systems on a breadboard, where you've got like hundreds of wires, and any loose connection can cause a havoc on your breadboard. Now, gone are those days. Nowadays, we've got tools like LT-Spice, Simulink, with MATLAB, Power Factory that I use a lot with CMTEQ channel, and ASYS. These help basically you simulate everything from small signal behaviors to grid-wide disturbances. Very important. Now, you can validate your design virtually, okay? Optimize efficiency and even test failure conditions all before touching the hardware. It is very much now possible, okay? Because of how those models of real components modeling have been integrated into software and systems that can actually simulate these behaviors. So it is pretty much easy to test your system digitally, almost like you're testing a real device. And then once you decide, you can move into the final prototype stage. All right, so we're going to take a very short break and we'll be right back. Hey guys, welcome back. So we are back on the second part of this episode 2 of CMTEQ Engineering PodCAST, and we are discussing is electrical engineering still matter in 2025. All right, so in this segment, we basically going to be discussing how engineers can stay ahead in these electrical engineering trends. So how do you do as an engineer to keep up in a world that's moving so fast, right? It's very difficult to keep up with the pace. Now, I'm going to give you just a few tips that you can hopefully maintain that with your busy schedule, and that's going to assist you with keeping up. So now, number one, you need to focus on the fundamentals. That's very important. That means you're going to eliminate lots of the noises and focus on the most important stuff, the fundamentals. So yes, the trends are exciting, okay? But you need to know Ohm's law, okay? That's still very relevant. V is equal to I times R. So if you don't have a resistance, you're basically not going to have a voltage, okay? And if you don't have a current, you're not going to have a voltage. So it's Ohm law. Very important. Now, and you also need to study Fourier analysis, feedback loops, and transient analysis. That's very important. Now, these are the foundations every trend is built on. You must know them. Okay? And number two, master at least one simulation tool. Don't split yourself into too many simulation tools and you end up not mastering all of them. Master at least one or two if you can. Okay? Now, if you work in power systems, I will say Power Factory is a good one, or ETAP, or any other power system simulation tool that's out there. Now, for electronics, you must learn LT-Spice, PSpice, or multi-sim simulations. In embedded systems, there are a lot of embedded system simulators out there, like Proteus is one of them. The Lab Center, you can simulate lots of MCU, Arduino, and the ST MCUs, and write almost real-time embedded firmware, simulate them, and then bring it to a real-life scenario, right? Or even the QMU for firmware testing, you can also use that one. Number three, you must build project. That's very important. Nothing replaces hands-on experience, okay? Even when you are busy doing your digital simulations of your project, you still need to bring it to the real world, because there are so many unknown behaviors that can happen when everything comes together in real life, that something unexpected is always expected. Okay, so and you build your skill set based on that. Your experiences, they come from that. So you must build a battery charger. Those are the good projects that you can start on. Build a battery charger. So if you have to charge your cell phone battery, which run off a 3.6 volt or a 5 volt, and if you want to charge it from a 5 volt USB charger, but if that USB charger need to connect to a mains power supply, which is 120 at 60 Hz or 230 at 50 Hz, that means you need to design an efficient buck converter that must step down from 230 down to 5 volt, and from 5 volt to perhaps 3.6 volt to efficiently charge your battery. So you're gonna learn a lot of sub fields in there, okay? And you must simulate your solar inverters, very important. And then write firmware for STM32 to log data for whatever project you are doing, okay? Then obviously you can discuss and share results with others online to keep the learning process going, because you can learn so much from others as well. And number 4, you must stay updated through communities. It's much easier these days. Just stay tuned with YouTube channels that are producing electrical engineering content, right? Like CMTEQ channel is one of them, and many other great YouTube channels out there. Read IEEE articles. Great articles are released every now and then, and participate in Reddit or Discord groups. Networking isn't just for job hunting, it's also for continuous learning. That's very important. It's how ideas spread. Then lastly, but not least, it's basically to stay curious. So you need to ask questions. Very important. If you find yourself in a forum or in a networking environment, in a social group somewhere, okay, discussing, ask important questions to stay curious. You must challenge assumptions, okay? Now, if you don't understand something, you must dig and dig and dig and dig until you do understand. Don't leave without understanding, because if there are people who understand a particular concept, that means you can also understand that concept. Don't leave without understanding it. And maybe in you digging, you might actually discover more than others are actually missing, okay? And then you might bring up an innovative idea, who knows, okay? So the best engineers that I know, they aren't the one with the most degrees. It's those who are continuously learning, okay? They keep on learning every day. They discover new things, okay? Just to wrap up for this episode number 2 of the CMTEQ Engineering podcast, quick recap will be that we've talked about electrical engineering. It's not just surviving, but it's basically thriving in 2025 and beyond. That's what you need to keep in mind, okay? And we've explored how power system, embedded system, and emerging tools are shaping the future. So if you are passionate about engineering or just want to understand the tech world more deeply, you are in the right place. Just stay connected and reach out. There will be more podcast release once a week or twice a week, depending, and we will be discussing different topics, like I said in the beginning. And if you have suggestions, you have a particular topic that you want me to discuss, put it down in the comment sections, and I'm going to grab that topic and then elaborate on that. Now, in the next episode, we'll dive into what makes the power grid smart, okay? So we'll explore the SCADA system, smart meters, and the demand response, and the communication network that keep the grid very, very intelligent. So if you got a question or a topic you'd like me to cover, reach out. The link to book a meeting with CMTEQ is on my main channel, and you can also leave a comment whenever you are listening to this podcast. And if you've enjoyed this episode, please make sure you subscribe and leave a thumbs up rating. That would be greatly definitely appreciated, and share it with someone who loves engineering as much as you do. So thank you so much for tuning in, and remember, stay wired, stay grounded, right? So that you don't get shocked, and keep learning. Thank you so much. Until next time, cheers.